Hello everybody, welcome back to another challenge of the page Adventjs.dev. In this case, we are in front of the challenge number 14 and this gonna be a easy level challenge. So let's read through the instructions so we can understand what we need to do. So it says reindeer need to move to occupy the stables, but there cannot be more than one reindeer per stable. Additionally, to keep the reindeer comfortable, we must minimize the total distance they travel to get settled. We have two parameters, reindeer, an array of integers representing the position of the reindeer, and stables, an array of integers representing the position of the stables. Each reindeer must be moved from its current position to a stable. However, it is important to note that there can only be one reindeer per stable. Your task is to calculate the minimum number of moves needed for all the reindeers to end up in a stable. So we have a note over here that says, keep in mind that the stables array will always be the same size as the reindeer array, and that the stables will always be unique. Okay. Well, we have here an example. Okay, basically this is the explanation, and as you can see, we are receiving two parameters. The first one is an array of all the reindeer's positions, and the second one is basically the stables. So okay, so as we can see here, the first reindeer moves from position 2 to the stable at position 3, and that represents one move. The second reindeer moved from position 6 to the stable at position 5, and the third reindeer moved from position 9 to the stable at position 8, and all of them represented one move. And if we sum they up, we have 3 movements as a total. Okay, so this is something interesting because as you can see here, the reindeers can move to any stables regardless if the stable is not at the same position as the reindeers. For example, in this case, the reindeer number 2 is not restricted to move only to the first stable, which is the number 3. It could move to any stable within the array of stables. The most important thing here is to find the nearest one. So the reindeers only move the least, the least movement, or the reindeers make the least steps to get to the stable. So whenever a reindeer takes an stable, that stable is not longer available for the remaining reindeers. So we need to keep that in mind. So basically we need to somehow mark each stable as taken when there is a reindeer in there. Okay, so let's do that. So basically, okay, let me think, how can I start this exercise? I think we are gonna start with a loop. Okay, so we have the index that's equal to 0, and this will increase their value as long as the index is less than the, well, it could be reindeer or stable length, because both has the same length, so it doesn't matter. Okay, so we need to calculate which is the nearest stable, in this case for the first reindeer. And then when we find it, we need to mark that stable as taken, or maybe remove that stable from the stables array, so we know exactly how many stables are remaining for the remaining reindeers. Okay, so let's call this as current reindeer. Okay, and it will be equal to reindeer that index. Okay, I think I will need to find the I will need to find the difference between the numbers of those arrays. So for example, the difference between 2 and 3 is 1, between 2 and 8 is 6, between 2 and 5 is 3. So we need to find the, how can I say, the minimum distance or the minimum difference between those numbers. I don't know, maybe we can create a function which is get difference, or let's call it get distance. Okay, so it will be first number and second number. Okay, so if I am not mistaken, there is a dev method of the math. I don't remember exactly. Let's see. Difference math diff. No. Well, it's basically we can calculate it as the first number minus the second one. As this can be a negative number, we need to get the absolute difference, and it will be equal to math adds of the difference, and we need to return the abs difference. Okay, so we need to find let me think. I think, for example, if we have here the tables, find index. Okay, for that table we want to find the index of the nearest stable for that reindeer. So we need to use the get distance function, and we'll need to pass, for example, it could be a stable and the current reindeer. Okay, now that we have that, let's call it as nearest stable index. Okay, okay, but we will need this value over here. Okay, so I'm gonna do this. For example, let's create a constant or a variable over here that says total distance traveled equal to 0. Here we can get okay, I need to think, because this gonna tell me the distance of all the stables, but I need to pick the minimum one. So to do that, okay, I think instead of a find index, we can use a map, and then we can save in the same position the distance instead of the tables. Okay, so let's call this as distance array, and this is gonna be and then we need to get, for example, minimum distance. It will be math.min, and we can pass the whole array, distance array, and this we will use that value to sum up it to the total counter. Minimum distance. Awesome. And then we need to find minimum distance index. It will be equal to distance array find index. Oh, I think it's index of that minimum distance, and this will tell us the index of the minimum distance, and it will be equal to the stable. So let's imagine in the first scenario we have the render number 2, and the nearest well, before that we are converting this array into the distance. So the first parameter of this array will be 1, because it's the difference between 2 and 3. The second one will be the difference between 2 and 8, which is 6, and this one will be 3 because it's the difference between 2 and 5. So this code over here will pick the minimum one, which is 1, and that is the value. So this is gonna be in the first iteration number 1, and then we need to find the index of the number 1, which is the distance, and it will return in this case the position 0, which is the first element. So now that we have this information, we need to remove that index from the stables array, so we can only leave the available stable for the remaining two, in this case these two renders. So let's do that. So for that we can use the stables array slash that slice, I think it's slice or splice, the beginning index of the specific portion of the array is starting on the front. I think it's splice. Exactly. Removes elements from an array, and if necessary inserts new elements in their place. So we need to remove the element at the position minimum distance index, and then how many elements we want to remove from there. I mean just one. So I'm gonna pass the number 1. So if I'm not mistaken, this method mutates the original array, so we don't need to reassign the stables array again. So I think with this code it should work. So the only thing that we need to do is to, well, in this case I have to replace total by the total distance traveled, and here we need to return the total distance traveled. So let's see what we get. Awesome. Well, basically we did it. It is looking great. This is not the as you can see, this is not the best approach. I am almost sure that we can even simplify this, but as I've been telling you all the videos ago, or all the videos I've been making, I want to try to make this video the as short as I can, as short as I can. That's I wanted to say. So, being said that, thank you for watching this exercise, this challenge, and I'll see you in the next one. Peace.